So, colleagues, good evening, or still afternoon, or is it evening? We are beginning the second session after lunch. It focuses on new technology and software solutions for RSD processing. The first presentation will be made by Mikhail Bolsunovsky, First Deputy Director General of Sovzond, Russia. Dear colleagues, with your permission, I would like to use my imagination a bit. It's great that the President and the government, everything and everybody talks about digital economy. I would take it even further and say that we have a new industrial revolution. The industrial revolution has been underway for several years. What is the essence of the new industrial revolution? Previously, we had mechanical tools, then technological lines, then computers, controllers, but now, in order to create new economy, combining biological, physical, intellectual and cybernetic resources, there are some buzzwords. Some of them are too tiring now. That is additive production, autonomous work, big data modeling, Internet of Things. So the technology combines the digital world with the real world, and it's difficult to imagine how you can do without computers. Computers can get into shared networks. This morning our Prime Minister Dmitry Medvedev joked, let's enter into the digital economy faster, as soon as we can, because machines may press the button and delete our brains. That applies to GEOIndustry, GEOIndustry 4.0. We believe that GEOIndustry 4.0 will come 15 years from now. We're still in the third version. We might have some elements of it 5 years from now. So it will be exciting to analyze what we have now, what we might have in 5 years. We decided to see how Sovzond can do it. We cover full range: satellites, UAVs, processing of data, geoinformation systems. Let's take remote sensing satellites. You know that the maximum GSD attained by WorldView 3 and 4 is 30 centimeters. SkySat can provide videos from space. Daily 3 to 5 meter acquisition from planet. About 200 satellites, with plans to bring it up to 50 with daily acquisition. A couple of other companies are following in the footsteps of the planet, so we're bound to see a lot of satellites and a lot of imaging. Regular radar imaging daily sub-meter resolution available from Cosmos SkyMed Tandem X, and access to data services. We develop a GEOIndustry platform. What will happen 5 years from now? We expect resolution to become even better. All vendors say we're gonna beat 30 centimeter mark and bring it further. The global coverage is gonna be 1 to 2 meter resolution. Video from space will become a standard product. There was an interesting presentation, joint presentation of Digital Globe with the Israeli partner, where they showed so beautifully that it's difficult to process the data that we have. Try processing videos. Qualitative growth of radar data. A Capella's satellite constellation was announced in the first quarter of 2018. It should be launched. That's what they promise. And they promise that the radar data is gonna be cheap. So, what we can do is sit and wait, without unveiling any specifications. Combined imaging modes, radar plus optics. You know, things are bad in terms of weather in Russia, therefore it's interesting to combine radar and optics. Several satellites twinned together to provide daily coverage of the Earth. Space and UAVs are going to be combined. Stratosphere, stereo imaging, development of data access services, and looking 15 years ahead, a model of imaging assignment will be transformed into access to geoinformation intellectual services. A user will ask a question and the system should be able to reply, provide an answer. It is desirable that it would be done informally. I mean, you just talk to the computer and the computer will tell you. Yandex has launched Alice. Alice can talk, right? We will teach computers to drink together, because there will be no people to drink with. Imaging will be made non-stop, and convergence with other sources of information. We keep talking about space, but there is also time and a lot of other factors. So all these information sources should intertwine, creating a common environment or common model that I will talk about later. UAVs. There was an Intergeo recently which we visited. I was just visiting. Rakurs had a stand. So it's the rapid growth of this area, but it's all the same. 30 to 60 minutes of flight, small UAVs, but laser scanners for drones like VUX or Velodyne become a standard. Hyperspectral cameras are mounted on drones. We're exclusive distributors of resonant Kuiper camera, which is in high demand. Automatic imaging of the area. We have Skywatch software. It's an automatic station for drones that allows, without human interference, to monitor an area with a fleet or with a group of drones. So if you have a drone, you can enter that network, and the customer should enter the network too. And the purpose of this service is to do matchmaking. So what are our expectations? You know about Elon Musk, that who set ambitious tasks. He said he's gonna make new batteries. In fact, number one task is to miniaturize batteries whilst enhancing their performance to increase the flight time of drones. Automated monitoring systems, AI, should somehow be integrated into this, including machine learning, making drones usage less costly, crowdsourcing. If you look at what the internet suggests, there's a lot of selfies that you can make using drones. A camera inside a phone is a great thing. I guess if you want, you can put a drone into your phone. Laser scanners, hyperspectral complexes, and heavy stratosphere complexes. 15 years from now, even though already now it's becoming very active. Is having the infrastructure for UAVs. You know, like cell communication uses towers, and they can be assigned with different objectives. Transportation objectives, mapping applications, imaging. But there is a lot of other infrastructure that drones can integrate into, like power supply. Full integration into geoinformation intellectual services, like DAAS. Aerial photography and laser scanning are still alive, doing good, as we know. Supply of high accuracy data. Heavy systems enjoy advantage because they have scanners, but the things are headed into UAV world. Of course, you can complex different data, but down the line, this is the slide prepared by me and head of remote sensing. So we agree that soon enough imaging will become more and more unmanned. It's going to be, you know, drones, small planes. At the moment, the level of automation is very low, 20 to 30%. We've seen some early offspring when the system can recognize certain objects or patterns, but still it's challenging to create a map. Russian mapping agency will be my judge on that. I mean, putting together the terms of reference is an ordeal enough. Several months or maybe half a year is needed to compile terms of reference or work statement. But there is no other alternative. The level of automation should be increased. We should be looking at machine learning, interpretation, object-oriented interpretation, some basic vector layers so that they would form the groundwork for future development. There is narrow specialization in the world of software. This open code software, GIS goes online, geoportals are implemented on that principle. Development of analytical services, and Agro GEOanalytics is specialized software for agriculturists, and object-oriented GIS. Recently, at a round table which I visited, discussed lively object-oriented GIS which make the system heavier, process heavier. Some of our colleagues say that it's the other way around. The productivity rate increases thanks to the object-oriented approach. 5 years from now, automation will be boosted. A map as a notion will be rethought. There will be rethinking of the map. We move into clouds already now, not 5 years from now, which is good. Information analysis algorithm is being developed, neural logic. And 15 years from now, there should be a way to talk to the computer informally and to model various situations upon request. In fact, what should happen 15 years from now is important for the user. Users are after the result, the output. A switch to intuitive tasking, and we should walk away from maps, I guess, and transition to new models based on dynamic spatial temporal model. It's a live map, a living map that keeps updating, and depending on the area of application, it addresses relevant assignments. Today or yesterday, there was some cutting, logging activities in a certain area. The area of logging, and the map changes accordingly. Next time there was a wind break, it should be reflected on the map too. It should be all on the cloud. In fact, we should be able to go into the cloud, ask the question, and it should provide answers. Thank you very much. Enough with fantasizing. Professional presentation, 19 minutes. Any questions to Mikhail? While you are thinking, I think Mr. Bolsunovsky offered a number of statements that can be disputed. For example, you mentioned intergeo. This was our 6th or 7th time. We walked it up and down, and we thought that the number of unmanned aerial systems has dropped dramatically. They are now limited to a certain room. There used to be a lot of interest and excitement, but now the technology stabilizes. I remember reading an article with a standard development curve with its peak and going down. So the UAVs have reached and passed the peak and now on a descending path. I also remember reading an article of a Russian scientist. The most effective imaging system is UAV. If a drone flies at 3 to 400 meters per hour at 4 kilometers with the top of the shelf camera. In other words, in terms of cost efficiency, 300 kilometers per hour is the best speed. I know of several developments when the payload could be 30 kilograms and they fly at the aforementioned speed. It's not a contradiction. In fact, it's very simple. It's all about the money. If this method is cheaper, if it's cheaper to walk, use your legs, it's gonna win. Any questions? Another question from me then. Mr. Chikurin in his talk was looking into the future. You do the same, but to look into the future you need to step back a little. We know that over the past 20 years in photogrammetry a hell of an automation has taken place, except for interpretation portion. In your opinion, percentage-wise, how is it possible to automate creation of maps using artificial intelligence? I think that it is possible. You know that computer beats chess players now. 15 years from now, the artificial intelligence should reach a level where it will be able to draw a map as good as an operator. But the point is, what is a map? An electronic map. It's a set of attributes in compliance with the regulations, but it's a kind of conservative fixed system. But let's take change detection. We keep referring to it. The same detection, change detection, that could be shown on our standard maps. Why don't we install it now? In fact, a living map I mean, even for the untrained specialist, it should be easy and intuitive to follow. In other words, things should become simpler. But if we are heading to better visualizations, machines help us look at objects very realistically. Should we even create topographic maps anymore? Maybe we should go to enhanced reality. I think we should answer basic questions. What is a map? It's a representation of reality using symbols. I talked to Sergei Serbiakov. Right, you. So we talked to Sergei. All our technologies should provide answers to specific questions. What, when, why, and how much? You raised a very interesting topic. I may have to ask Professor Chebunichev. All sciences are developing differently at Mikhail. Neural networks. Maybe we should focus more on that side than basic mapping. Training and learning should develop and is developing across all the areas that we mentioned. I very much like the presentation by Mikhail. My thinking is the same. The education process is changing as well. There is a lot of conservatism in that, of course, and it's not going to go away, but we undergo changes. And all the notions that we are discussing now are communicated to students. Great. Thank you. A very interesting subject.